Hello, welcome. In this short video, let us look at some more relations between complex numbers. First one is e power z conjugate is equal to e power z conjugate. Starting with the LHS, we have e power z whole conjugate. It is conjugate of exponential of a complex number is given by exponential of x plus jy whole conjugate. And then we can rewrite this as e power x into e power jy whole conjugate. And now e power x is just an amplitude since it is a positive number. So it is e power x into e power minus jy, which is equal to e power x minus jy. And x minus jy is nothing but conjugate of the complex number z. So it is e power z star or z conjugate. Next relation is the following: z1 z2 conjugate plus z1 conjugate into z2 is equal to 2 times the real part of z1 into z2 conjugate. Starting with LHS, we have z1 into z2 conjugate plus z1 into z2 conjugate whole conjugate. That is, we are using the relation z1 into z2 whole conjugate is equal to z1 conjugate into z2 conjugate. So by using this relation, we can rewrite the second term as z1 into z2 star whole conjugate or z1 into z2 conjugate whole conjugate. Now this one is just like a complex number plus conjugate of the original complex number. That is, if you assume that z1 into z2 star is a single complex number, say z plus, then this is z conjugate, where z is equal to z1 into z2 conjugate. And we know that the sum of a complex number with its conjugate is equal to 2 times the real part of the complex number z. Therefore, z1 into z2 conjugate plus z1 conjugate into z2 is equal to 2 times real part of the product z1 into z2 conjugate. The next one is the absolute value of a complex number z is equal to the absolute value of its conjugate. Starting with LHS, we have x plus jy, that is absolute value of x plus jy is given by x square plus y square power 1 by 2. And the absolute value of x minus jy is also given by x square plus y square power 1 by 2. Therefore, absolute value of z is equal to absolute value of z conjugate. In other words, conjugation does not really change the amplitude, it only changes the phase or inverts the phase. Next, we want to show that the product of two complex numbers z1, z2 has an absolute value which is equal to the products of absolute values of the individual complex numbers. That is, absolute value of z1 multiplied by z2 is equal to absolute value of z1 multiplied by absolute value of z2. So starting with LHS, we have z1 into z2, and then we have absolute value is equal to x1 plus jy1. Here of course we assume that z1 is equal to x1 plus jy1 and z2 is equal to x2 plus jy2. And then we have absolute value, and this is equal to x1 into x2 minus y1 into y2 plus j into x1 y2 plus x2 y1. Therefore, the absolute value is given by x1 x2 minus y1 y2 whole square plus x1 y2 plus x2 y1 whole square power 1 by 2. See, this is the absolute value of the product z1 and z2. Now let us look at the product of absolute values of z1 and z2. This is equal to absolute value of z1 is given by x1 square plus y1 square power 1 by 2 multiplied by x2 square plus y2 square power 1 by 2. And this is equal to, when you multiply the bases, we have x1 square into x2 square plus x1 square into y2 square plus y1 square into x2 square plus y1 square into y2 square whole power 1 by 2. Now, by adding and subtracting 2 times x1 x2 y1 y2 to this term, that is 2 times x1 x2 y1 y2, and then minus 2 times x1 x2 y1 y2 to this term, we have x1 x2 minus y1 y2 whole square. That is, by combining x1 square into x2 square and y1 square into y2 square with and minus 2 times x1 x2 y1 y2, we have a minus b whole square, that is x1 x2 minus y1 y2 whole square. And similarly, we can also have x1 y2 plus x2 y1 whole square. That is, by combining these two terms with this 2ab term, we have a plus b whole square. And then we have, of course, power 1 by 2. And now if we compare the results, the absolute value of the product z1 z2 is clearly equal to the products of absolute values of z1 and z2 respectively. The product of absolute values of z1 and z2. The next one is that the real part of a complex number is always less than or equal to its absolute value. This one is rather straightforward. That is, the real part is given by x, and then the absolute value is given by x square plus y square power 1 by 2. And since x square plus y square is always greater than or equal to x square, since y square is always non-negative, this is true. Therefore, by taking square root on both sides, we clearly see that x square plus y square power 1 by 2 is always greater than x for x greater than 0. And for x less than 0, which is a negative number, it's always going to be less than any positive number. Therefore, this is true for all values of x that belong to the real numbers. Therefore, the real part of the complex number z is always less than the absolute value, less than or equal to the absolute value of the complex number. And finally, we will prove the following inequality. That is, absolute value of z1 multiplied by z2 conjugate plus z1 conjugate into z2 is always less than or equal to 2 times absolute value of z1 into z2. Since we know that from the previous one of the examples or one of the relations, we know that z1 into z2 conjugate plus z1 conjugate into z2 is equal to 2 times real part of z1 into z2 conjugate. Now, by using this relation, and then we also know that real part of a complex number z is always less than or equal to its absolute value. Now, letting z is equal to z1 into z2 conjugate, that is z equal to z1 and z2 conjugate, then we know the real part of z1 into z2 conjugate is always less than or equal to absolute value of z1 into z2 conjugate, and which is equal to z1 into z2. That is absolute value of the product z1 and z2. Now, by using this relation, we can clearly see that z1 into z2 conjugate plus z1 conjugate into z2 is clearly less than or equal to 2 times the absolute value z1. Therefore, the absolute value of z1 z2 plus z1 star into z2, that is absolute value of this real number, is always less than or equal to 2 times z1 into z2. Only difference between these two expressions is that we ignore the sign of this real number, and therefore its absolute value is always less than 2 times this absolute value of the product z1 into z2, which is always the absolute value is always a positive real number. Thanks for watching.